So in that case, we're not going to use the integration, but we're going to use the probability function. How? Let's see. Now, probability of x 495, this function is given, so it will be function of 5.1 minus function of 4.95. So first we have to define this function, right? That what is this function? So it will be the probability of x is less than equal to 5.1 minus probability of x is less than 4.95. Now we have to define this function. So first let's make the distribution function. That is, we know f of x equal to integration of 4.9 to a particular point x, remember, and 5 of x d of x. That's the probability density function, that's the given, right? So we just solve it out, and we will get 5x 4.9 and x. Now this diagram you understood, so I'm just gonna erase it. So in this case, what will be the distribution function of this variable? So if I solve it, I can open it as 5 of x minus 4.9. This is constant. So what is the distribution function for this? That's what we have to calculate. Right? Simple. You can calculate it, right? Can you? We can use this one in order to compute probability. So if you put 5.1 in above in this function, what will you get? Function of x 5 times 5.1 minus 4.9, because we need this function, right? So this is 5.1. We get 5 times 5 minus 1 minus this function is this. So minus 4.9. So that's the first function, f of b minus f of a. What is that? 5 into 4.95 minus 4.9. This is f of b. Do you understand? Because we have this function, right? F of a, 5.1 is this one. F 4.595 is this one. Now simply solve it. When you open it, you will get 5 times 5.1 minus 4.9 minus 5 times 4.95 minus plus 4.9. So this will be cancelled out. Remaining 5 common. 5.1 minus 4.95. 5 times 0.15 equals to, this is equal to 0.75. So it's again the same as what we have found out through integration, right? Do you understand this? Is it clear? Is this one clear? And similarly, you can find out this one, which you will get eventually 0.50. Right, so let's move to the slides, and if you see next one, that's a bit different. Continuous variable, random variable. That's example 2. In example 2, it's given. What is given? Let's see. We have a probability function. Function is given as 20 minus 20 x minus 12.5 for all x is greater than 12.5. Now it's an exponential function, right? So if we put the values of x in this function, we draw it and it look like an exponential curve. What is an exponential curve? Exponential curve is like this one, right? X and function of x. Now here at this point we have 12.5. So x is all this range up to infinity, right? So whatever x is greater than, that's it. So in this case, the probability of x we can calculate in an exponential form, but this probability is 0. For example, he is asking us if he's asking us that find out the probability of x is greater than 12.60. So first thing we have to see that if this the asked probability is lying in our range or not. So what is the range here? Range here is 12.5 to infinity, right? So yes, it lies here, right? For example, if he could have asked me like the probability of x is greater than equal to 11.4, then we would simply say it's 0 because it's x is a point at here at a level below the range, so it doesn't fall in a range. So we just simply, so whatever which is not in a range, we just simply say it's 0. Do you understand? So this is a function of a diameter of a product. Diameter of a product. So that's why it's a continuous exponential function, right? So if the diameter is greater than 12.5 milliliter, what is the millimeter? What is the value? Now this we cannot, because this is simply 0. You just simply say probably, but this lies in under the range, so that's easier to calculate. So how are you going to calculate it? Simple integration. You can apply both, but it's easier to apply integration. Probability of x 12.6, I have already written it. So this will be integration of 12.6 to range. What is the range? Infinity, greater than, right, until infinity, f of x d of x. So can I write in this way? Infinity. What is x? F of x, this function is given 20 minus 20 x minus 12.5, right? So from integration output, we know that integration of ex dx is equal to e of x. So if this function is same as x, because here it's 1, here it's 1. So if it's 1, right? So 1 times e power x and e power x is the same constant, because the constant with the variable is 1. Here in this it's minus 20, right? But here it's e power, that's e power, right? So it's minus 20, but here it's plus 20. So what we do, we just multiply minus and minus from inside. Now this is the property of ex, right? So what we get is minus e power minus 20 x minus 12.5. That's the integration of the function from the range 12.6 to infinity, right? You got this. Now put the value inside it. So when you put the range, b is infinity. So when you put the range, so you will get e minus infinity, right? plus, because minus minus plus, right? Actually it's minus and then minus e, so it will be plus e power. Now put the value 12.6 here. So what will you get? 12.6 minus 12.5, 0.1, 0.1 into 20 minus 20. What will you get? You will get minus 2. So we know we can write this one as minus e upon 1 upon infinity plus e 1 upon 2. So it will become minus e power 0 and plus 2.7. We know the value, power 0.5. So this will become 1 as e power 0 right? So we will get the value of 0.135. So there is a 13.5% chances that the diameter will be greater than 12.5. So that's how you calculate. So in part B, he's asking that what is the probability of x is between 12.5 to 12.6. So doing the same thing, and you will solve it and you will get the probability of 12.5 and 12.6. Does it fall in a range? Yes, it does fall in a range. So you solve it in this way and you will get the values, and the solution will be 86.5% from the B part. So that's how we calculate the continuous variable. So do you understand? Is it clear to you? Is it clear? Okay, good. So now you know how to get the probability function of a continuous probability function, how to get the results. Now let's take a special case of a continuous random variable, which is normal distribution. We are moving to a specific type of a continuous variable. Just like in discrete, we learned about the Poisson, Bernoulli, binomial, Poisson, and hypergeometric. In discrete, we are moving to a specific type of continuous variable distribution, which is also called as a normal distribution. Normal probability distribution. It's nothing new. You already have somehow know about this distribution. Right? How? Let's see. But the problem here, the function, probability density function of a normal probability distribution is a bit complicated. So first, let's see what is the function. I'm not getting into the proof. You just need to know what is the normal function. So it's sigma 1 upon sigma under root 2 pi e power minus 1 by 2 times x minus mu upon sigma square, with a range r of x is defined as minus infinity to infinity, which you can also say that minus infinity x and infinity. So that's the normal probability distribution function, right? So you can either solve in this way or you can simplify it further. We will see how we can simplify it. Now remember, just like in discrete, we also have a parameters here. So in normal distribution, the parameters are mu. So anything is normally distributed with mean mu and variance sigma square or standard deviation sigma. Now, what is this mu? Now, what is this mu? Remember, mu is a locational parameter. And of course, sigma, it indicates what? It indicates the deviation, the dispersion, right? So it shows the shape, indicates shape of distribution. So we call it as a scale parameter. So mu is a mean, is an average locational parameter. We will see in a graph. So it's symmetrical. Remember, a normal distribution is a form of is a symmetrical distribution, which means mu is in between exactly, and both are the halfway. We have already talked about this. So this range is plus infinity to minus infinity, right? So what is the sigma? Sigma is showing the variation from here side is a positive variation, and from this side is a negative variation, right? So that's the distance it's showing. So if you remember the histogram, in discrete we used to build a histogram to check the data flow, right? So it's symmetrical. But this is descriptive approach. We will also talk about the inferential approach, where we apply different kinds of tests against it, that the data really following the normal distribution or not. But for now, just keep it with the descriptive approach, and we assume that you can make a histogram and you can see the shape if it's normal distribution or not. And the range is given between minus infinity and infinity. That's the central value. Mu and sigma shows the variation of the rest of the data to its average point. So I hope that you know empirical rule. What is the empirical rule? Do you remember empirical rule? We have learned about the empirical rule. What is empirical rule? It is that the distance of a sigma of a mu, it can be divided into three different standard deviations, right? One is mu plus minus sigma, mu plus minus 2 sigma, remember? And mu plus minus 3 sigma. So the whole data is distributed in such a way that mu plus minus 1 sigma explains 68.4%, if you remember correctly. Mu plus minus, it was 95%, I think. And it was almost 99.73% in a symmetrical, in a normal distribution. Remember? So you have to, that's why we already covered these topics, because now these topics can come again and again, so that you should be in mind that what I'm talking, if I'm not talking about the empirical rule, because not every time I'm going to write this. So if I say empirical rule, it should come into your mind that what I'm talking about or what I'm indicating to. Now it says that this percentage data lies under the curve of this one. So if mu of sigma plus sigma is this one, and this one, so 68% data lies in here. You remember the quartile and Q1, Q2, Q3, right? It's the same concepts about the empirical rule. So how to interpret sigma? So we can say as sigma increases, the curve becomes flatter and away from the mean point, not in a sense of a distribution shape. It's going to be normal distribution, but it will be here it's normal, but if sigma decrease, so there will be a more flatter distribution. The mu is in between itself, right? But its sigma will be, the distance will be further, and here as well. So this sigma deviation is further from the mean. So as sigma increases, width of the distribution increases, right? If sigma decreases, width decreases as well, and it follow this. So this is also normal, but here sigma is really less. See? So that's why standard deviation is really important, as we have seen in the function. Let's take a quick example. For example, that is, so this you understand, right? So is it clear? Can I erase it? Is it clear? Okay, perfect. Then I continue. Now we have to deal with the function, because as we know, the function, normal probability function, right, f of x is not an easy one. It's this one. It's a complicated one. You can solve it, but it's gonna take you too much time. So why not to make it easy? Do you know how can we make it easy? You have seen this, you have learned this, not in detail we're gonna do now. So this is the probability function with a range of minus infinity to infinity, right? Instead of using this function, what we can do, we can convert this function into a standardized form, which is known as standard normal distribution. Now remember, here the parameters are mu and sigma, right? And is mu and sigma. So it's also a normal distribution, but the standardized. We need to convert it. How we gonna convert it? So we know that x is normal random variable. So we convert this x into standard normal variable by z-score. See, now you have heard about this. So what is z-score? Z is x minus mu upon sigma. When we will solve the example, we will see how we do that. But first, remember that it's also normally distribution, but here mean is 0 and 1. So whatever the distribution is, let's say this is the distribution of mean, mu, and sigma. So when we standardize, this becomes 0, and we have to see around the values around the 0. So now incorporate this value in this function. So what will you get? You get z, function of z. This is a function of x. Now we have another, let's say this is a function of z. F of z will become 1 upon 2 pi under root. Why? Because here we know mu is 0 and sigma is 1. So I just put 1 instead of sigma. That's for sure. And any standard normal distribution, it's given. Because it's how it does, we will see in a while. So here it will be e 1 by 2 power z square. So now we simplify it. So once we simplify it, now we can solve it. So first you have x given, you find out the mu, you find out the sigma. I'm telling you in terms of a table. So if x is given, you have mu, you can calculate the mean, you can calculate the standard deviation, and then you can calculate the z. And that you can get the distribution, then just put that distribution here. You can integrate it, right? Rest, you're gonna integrate this function from minus infinity to plus infinity. So what will it be? It will be, if you integrate this function, what will you get? It's the integration of minus infinity to infinity of 1 upon 2 pi. That's a constant, 1 upon 2 pi, so take it outside. Under root, and inside is e minus 1 by 2 z square, right? And d of z. Now just solve it and you will get the result. So one way is to integrate by yourself. Another way, the table is already given, the integrated table is already given, and I have shared with you. So in a while, when we will do the example, we will also open and how to use the chi-square distribution, right? So how to do that? Let's see. This table, you can see once you get the z-score, once you get the z value, you can see the table in this form. No. So that's the table. That's the table. It's known as, there can be many z tables. There's also like a z table for a cumulative distribution. But here we are learning about the z table of a normal curve area. So you can download it by yourself, but I have already given it to you. So on this side is the value z, and on the other side is the decimal of the z. For example, z is 2.39 or 1.39. So I will see 1.3 here and 9 is here. So it's this value, 0.4177. So that's how we find out the z table value. So now let's move back to this whiteboard. So, and we can use the z-score. The value it's known as an area under the standardized distribution. So let's take an example. Right? So in case of a z, function of a z will be 1 upon 2 pi under root e minus half z square. Right? Now, let's take an example. Mu is given, let's say, 10 minutes. Mm. So this is an example. A production supervisor finds out that employees on the average complete certain task in 10 minutes. So what is given? Mu is 10 minutes given. The times required to complete the task are approximately normally distributed with a standard deviation of 3 minutes. So sigma is given, which is 3. He is asking us to calculate a proportion of employees completing the task in less than 4 minutes. So what I have to calculate is x less than 4. That's what I have to calculate. So that's the question. That's a question. So this is given, and this I have to find out. Now, if I make a graph, so what is this? So here, mean mu is 10. Here it's x, and I have to get x equal to 4, and I have to get less than 4, right? So this probability I have to calculate. So what here? The same value in normal distribution, standardized normal distribution, it's the same thing, but here mu is 0. So first we have to convert this x equal to 4 into standard normal variable. So what is x? Z is x minus mu upon sigma. We know it's 4 minus 10 upon 3, which is minus 2. If you solve it, you will get it 4 minus 10 is minus 6, and then minus 2. So it is here. So right below I'm doing it so that it's easy to compare. So now I have z minus 2. So 1 is, we can put 2 decimal. So one way is to do this, integrate this function. And what will be this? How to solve it? Where do I solve it? Just like here. So instead of minus 2, I will put minus 2 here, z, and it will give me 4. 4 and 2, 2, 2. So it will give me 1 upon 2 pi. Sorry, first we need to integrate it with the range. So either you can integrate it, it will be integration of this one, 1 upon 2 pi in minus infinity to plus infinity. And what will be the integration result? Put this value there in the range, and finally you will get it. Or in another way, you can just find out the table value in this. So in this case, so I have z as minus 2. So it regardless minus, so we don't consider minus here on a z table. We get the value of 2. So what is the value of 2? is I have to show you one more thing. 2.00. So 2.00 is 0.4772. Now this is the value. That's how you select the value. So I got the value. So here, instead of this value is, remember, this area is how much? 0.5. This area is 0.5. I have to calculate this area. All right. And what is this area? This area is 0.5 minus this area. Right. So this area is 0.4772. See, we got the value of this area. So z value of -2 is 0.4772. So it means this range, it shows us this range is 0.4772. This complete, let me not confuse you. Let me make a new one. So this is z. This is mu 0, and this is the value of z at -2, which is 0.4772. This area. Now we are interested in finding the probability of this one, right? So probability of z as -2 is this one. This area is 0.05. So what will be this one? This one will be 0.5 minus 0.4772, right? Because probability of x is less than equal to 4 is equal to probability of z less than -2.0. Do you understand this? So if you calculate, if you minus this area is 0.5, this area is 0.47, so what is the area of this one? So 0.5 minus 0.4772 equals to 0.0228, which means 2.8%. So there are 2.8% chances, 2.28% chances that x is less than 10 minutes. Is it clear? Is it clear? I repeat. So what you do, you have mu, you have sigma, you first convert x into standard normal variable z, you get it -2. You see the table value, you can integrate if you want, but now it's easy because we have the table value. You look into the table, the value of -2 against the decimal of 0, the value is 0.47. Now this probability, probability shows at the probability of -2, which is at this point. So this area is 0.4772, and the same times here it happens because it's negative, so that's why I'm telling it the value of on the left side. So if we, from this whole area is 0.5, if we subtract this area from 0.5, we will get this segment, which we are interested in, because we are not interested in x equal to 4 or more than 4. We are interested in x is less than 4. So that's how we calculate. Is it clear? Is it clear? Do you understand? Now you can hear me, right? Are you clear with this? Okay, now I got your response. So only 3 of you are responding me efficiently. Okay, thank you. Now we will see the B part. What is the B part? If you open the slides, you will see the next part, and we do that, and the third part you will do it by yourself. So let it be like this, because this is the information we have. In the B part, it's saying that the proportion of implies requiring more than 5 minutes completing the test. So at the B part, it's saying it's more than 5. So mu is 10 sigma square. So now you have to find out the probability of x is more than 5. Now how to do that? Simply convert first this 5 into z. Right? So here the mu changes, the x changes to 5. There it was 4. So again, you can draw the same. So here you have to 0, mu is 0. So convert this one into, what will be the z? X is 5. 5 minus 10 divided by 3. What you get? 5 minus 10, 10. 10 minus 10 by 3. It's like 3, 1 point something, right? How 3, 1, 2, 1.67, right? So just see the counter value of 1.67 in the table, and you will get it. It's 1.60123457.4525. So 0.4525. That's the value. Now it's telling us to get the x is more than 5, right? So 5 comes at 10, 5 comes here, so this value is 1.67 comes here. So it's more than 5. So now remember, this is 0.5 area, and this area is 0.45, almost 25. So total area will be 0.5 plus 0.45. Then it will be x is greater than 5. Now we are interested in this area, right? So this area is this plus this, and we will get it 0.9525. So there is a 95.25% chances that it belongs to this area. So that's how it becomes very simple. So the probability that an employee who has just assigned the task will complete it within 3. Right? So that you can do by yourself. The third part. Now let's take another example. It's a bit in a different way. So you have to know that how to read the information, right? So in this example, we have given y equal to 5 of x plus 10. This is given. X is normally distributed with mean mu is 10 and sigma square is 5. So it's mu of x, sigma square of x is given. He's asking us to find out the probability of 52 less than y less than 67. So he's not asking about the x. So first we need to find out mu of y and mu sigma square of y, right? So how to do that? So we have this equation, right? So y equal to 5x plus 10. So take the expectation on both sides, all right? So we know the expectation of a constant this will be 10 will come itself as it is, and 5 expectation of x will be as it. That's a property of a mean, right? E of x equal to x plus 2 or a, then E of x plus a, right? We have already learned about these properties. So it will be as it is. So we know we have expected value of x is given as 10. So 5 into 10 plus 10, so it will be 50, and 10 60. So we know have mu of the y is 60. That's we calculated. Similarly, you can apply the variance. We know the variance of constant is 0. So what we get, 5 and 5 constant and x square, variance of sigma square x, right? Variance of x. So what will be it? It's 5 times 5. Oh, so its sigma square is given 25. So 25, 5 square, constant square. We know variance of ax equal to a square variance of x, right? So the same thing we apply here. So it's sigma. So sigma square x value is 25, which is 625. So we know that this is also 625, right? So sigma of y, it's given as 25. Right? So now we have the value of y, mu y, sigma y. We have to find out this y, so it's now easy. So now you can calculate. So 52, first you change 52 into z, and what will be the z? In there it's like x minus mu upon sigma, so 52 minus 50, 2 minus 60 upon 25. What is it? So this is the normal graph. This is mu, which is 10, in this case, which is 60, and this is z1, this is y1, which is 52, this is y2, which is 67. So this is z1 equal to 52 minus 60 by 25. This is 67 minus 60 by 25. z1 is equal to 52, 8 by 25, and this is 7 by 25, and this is 0. Right? So this is in terms of a 0. So 8 by 25, 7 by 25. Check out the values in the z table and get the probability. So do you understand today's lesson? So now you are done with the continuous random variable and normal distribution. Oops. Wait, just give me 1 minute. I think that the computer, that this was not clear. So for this, first you change mu of x, and you put the values, and you find the mu of y equal to 60, sigma square y is equal to 625, right? If you see it clearly now. By applying the expectation, the properties of variance and properties of mu. So if you apply the property of mean, it will be expected value of y, it becomes 5 times expected value of y, which is 10. It's 5 times 10, 50, and plus 10, 60. Similarly, variance is 5 squared and expect variance of x. Variance of x is 25, so it will be 625. So I can get sigma y is 25. So I have these two values. I just put in this value and I can get z1 and z2, and now you can calculate this region for y easily. So you can do this at home and also next part. So hope that you understood